Guys, we are now preparing you guys for the prelims and for the final exams, grade 11s and 12s. So now, these are important concepts in functions. We are busy with functions and that's where we're going to end up today. So now, we're doing exponential, the exponential graph with the shift in asymptotes. So the first thing, we know that this is given in the form y equals a to the power x minus p plus q. So now, we know your standard graph is a to the x. The minute you have a p and q value, we know that the graph is shifting. And this here, your q value represents your asymptote. Right? So we know that our q value is equal to minus 4. They might say, give the equation of your asymptote of the graph. So y is equal to minus 4 because the q value is a straight line going through minus 4. So if we had to draw that, that's your asymptote going through negative 4. Right? That's your q value. Y equals negative 4. Now in order to sketch this graph, right, I'm just going to work out here, do the calculation on this side. So you've got y is equal to 2 to the power x minus 3 minus 4. We're now going to say let x equal to 0. So if x is equal to 0, y is equal to 2 to the power minus 3 minus 4. So y is equal to 2 to the power minus 3 because that's 0. 0 minus 3 is negative 3. 2 to the minus 3 is 1 over 2 to the plus 3, which is 1 over 8 minus 4. So y is equal to minus 31 over 8. Now you can use your calculator to check that out. 1 over 8 minus 4 is minus 31 over 8. Now we go on to let y equal to 0. Let y equal to 0. So now we're going to say 2 to the power x minus 3 minus 4 is equal to 0. 2 to the power x minus 3 is equal to 4. Remember, we're solving for x. Remember from our topic in our previous episodes on exponential equations, we now got to make our basis the same. So now we're going to say 2 to the power x minus 3 is equal to the number 4. We're going to make it to the same base, 2 squared. 2 and 2 cancels. X minus 3 is equal to 2. X is equal to 2 plus 3. X is equal to 5. So where x is 0, y is minus 31 over 8. Where y is 0, x is equal to 5. And we know that our asymptote is, S for asymptote, is y is equal to negative 4. Let's now go and let's sketch our graph. So this was just a rough sketch to show you where your asymptote would lie. Let's now go to our graph. So there's our graph, there's our Cartesian plane, y-axis, x-axis, that is 0 there in the middle. Okay, your asymptote y is equal to minus 4. Minus 1, minus 2, minus 3, minus 4. So there we go, and we put a dotted line going through minus 4. That is your q value, that is your asymptote. Now you got 0 and minus 31 over 8. So negative 31 over 8 minus 31 over 8 equals minus 3, 8, 8. So minus 1, minus 2, minus 3, 8, 8. So that would be there, right? So 0 on my x minus 31, 8. That's your first point. Your other point is 5 on your x and 0 on your y. 5 on your x. 1, 2, 3, 4, 5 on your x, 0 on your y. Okay, it's a positive exponential. It's a positive. So we know a positive exponential goes in this direction. So the graph is going to go in that direction. And that is the shape of your function. Okay, there are your two coordinates, 0 and minus 31 over 8. So this point here is 0 and negative 31 over 8. And this is your other coordinate, 5 and 0. And there we go, boys and girls, that is your exponential graph that has shifted. Okay, what is the equation of your asymptote? Y is equal to minus 4. What is the domain? What is the range? The domain will still be x is an element of real numbers because, let's just put it here, the domain, x is an element of real numbers because any x value here will give you corresponding y values on your graph. What is the range of this graph? What's your lowest y value here? Negative 4. And is it going down to negative infinity or positive infinity? To positive. So it's from minus 4 up to positive infinity. Minus 4 is excluded. Why is it excluded? Because the graph will never touch negative 4. And infinity is always excluded. And there we go. That is the domain. That is the range of that exponential function. Okay, so that's how we sketch it. We take out our asymptote. We then do our dual intercept method. Let x equal to 0, solve for y. Let y equal to 0, solve for x. Okay, good. Let us now go on, what if this graph is given? Now guys, this is important and this is heavy stuff. So please pay attention. Here we're going to be involved with simultaneous equations. So this is where the candy hits the fan.